In this video, we'll work through a couple more examples to help you feel a bit more comfortable with the formulas for conditional probability. As a first example, this one won't yet use any conditional probability. Let's say you roll 2 dice and you're interested in the probability that the sum total of the 2 rolls is more than 10, that is 11 or 12. So remember that, that this is the probability of one of 3 outcomes, 5, 6, or 6, 5, or 2 6s. And this is equal to 3, meaning there's 3 outcomes there, divided by the total number of outcomes, which you'll remember for this case is 6 times 6, 6 for the first roll and 6 for the second roll, equal 3 out of 36, or 0.08. So now we can add some conditional probability. And let's say what's the probability that the sum of the 2 is more than 10, given that the first roll is a 5. We'll look at 2 different ways of calculating this, one through counting and another through the actual formula. So first, if we just kind of think about counting the events, I've listed out the 6 events that satisfy the first roll being a 5. And out of these 6 events, one of these events has that the first roll is, or that the sum of the 2 rolls is greater than 10, namely the event 5, 6. And so the probability that I roll 2 rolls that add up to a number greater than 10, given that the first roll is a 5, is equal to exactly 1 in 6. We can also see this formally using the formula from last video. Now the formula is the probability of A given B is equal to the probability of A and B divided by the probability of B. And so here we'll define our events. A is the event that the sum is more than 10. B is the event that the first roll is a 5. Now the probability of A and B is the probability of the single outcome 5, 6. It's the only one that satisfies both events. This is 1 in 36. The probability of B is 6 in 36. You'll remember the 6 outcomes from the last slide are the outcomes in which the first roll is a 5. So now we can combine them according to the formula. Probability of A given B is 1 out of 36. This is probability of A and B, divided by the probability of B, 6 out of 36, which is equal to, in total, 1/6, just like before. One more example, this time with another version of the same formula. So now I'm pulling 2 aces from the deck, and I'd like to pull them from the deck, and I'm curious what's the probability that the first card that I draw will be an ace, and the second card is an ace. Remember, if these were independent events, we could just multiply the separate probabilities. But they're actually not, and so we'll use this formula. The probability of A and B is equal to A given B times the probability of B. So let me write, just so that you remember, A here. In this case, I'm going to define it to be the event that the second card is an ace, because it'll turn out to be a lot easier to calculate. And B is the probability that the first card is an ace. Okay, so now we need a couple of things. First, the probability of B. This is the probability that the first card is an ace. This is 4 out of 52. There are 4 aces in a deck. We also need the probability of A given B, which in this case is the probability the second card is an ace given the first is an ace. And if we think about this, the first card's an ace, which means that there are 3 aces left in a deck of 51. And so now to get at our probability of interest, remember we want the probability that both are aces, probability of A and B. This is equal to, remember the formula, A given B times B. And we have these already calculated. This is 3 out of 51 times 4 out of 52. Ends up being about 0.0045. These formulas for conditional probability will be useful as you think about processes that evolve and using information to adapt your probabilities of future outcomes happening.